Hello students, welcome to the online class for automobile engineering drawing. The subject code is AED. This particular subject in terms of a practical class is present in your third semester diploma syllabus under Department of Automobile Engineering. So today our primary concern is on the practical number 2, that is having the topic like production drawings, general welding symbols. So we'll today basically learn about the topic like general welding symbols. So let me first introduce myself. My name is Tanmoy Kundu, Assistant Professor, Department of Automobile Engineering, Dr. Sudhir Chandra Su Degree Engineering College, Kolkata. So here you find this is the course objective. So understanding of drawing, which includes clear spatial visualization of objects and the proficiency in reading and interpreting in a wide variety of production drawings, and also developing drafting skills. Next, come to the course outcome. The students will be able to interpret the industrial drawings, interpret the various symbols shown on the drawing, and selection of manufacturing process accordingly, use IS convention of representation of various machine components, visualize and draw details from assembly drawing and vice versa. Know the significance and use of tolerances of size, norms and positions. So let us start with our today's topic, lecture number 3, practical number 2, introduction to welding and general welding symbols. So above everything else, first of all we have to be very much introduced to this topic. So introduction part, we will first learn that what is welding joint. So welding joint is basically a permanent joint. So once the joint is made, it is not possible to break. So it is called the permanent joint. So welding joint is a permanent joint which is obtained by fusion of the edges of the two parts. That means you are applying some heat, and due to this amount of heat, when the temperature rises above the melting point temperature of the parent metal, so at that time what will happen, the parent metals will come at the molten stage. Okay, so during that when the two metals will be at that molten stage, so the joint phenomena will be happen, but not necessary that every time that melting phenomena will occur. Okay, so there is a fusion means there will be a large amount of heat will be generated. Okay, now we see there is a application or without the application of pressure. That means mostly the primary resources for a welding joint to be done is the heat. Okay, now once heat is there and the amount of heat is very high, so we do not need any external pressure. So in that case only heat can be sufficient to make the welding joint. But there are few welding joints where we use heat as well as the external pressure. So the important resources of welding to be done are heat and pressure. But heat is always essential, pressure may be there, pressure may not be there. Okay, if you go through the part in detail, so as I will discuss everything else in detail, so there will be two different types of welding, fusion welding and pressure welding. Okay, so in the fusion welding, like we will discuss in the like arc welding or any gas welding, so where heat is sufficient. Okay, so there is a particular in this type of weldings we do not record any external pressure. But other pressure weldings like resistance welding, spot welding, okay, so these are the different weldings where we see that there will be applied some amount of heat, and additionally we have to apply the pressure, okay, to get the welding joint completely done. Okay, next we see it's a filler metal. Okay, so filler metal may be used, filler metal may not be used depending upon the welding process. Okay, so these are the different welding different resources that are very essential to get the welding job done. Okay, the heat required for the fusion of the material may be obtained by burning of gas in case of gas welding, or by an electric arc in cases of electric arc welding. Okay, so where from the heat is generated. So there are primarily two resources for getting the heat. One is the electric arc. Okay, so electric arc will be generated in case of the arc welding. So TIG welding, tungsten in inert gas welding, MIG welding, okay, then SMAW welding, shielded metal arc welding. So there are several arc welding process we see that where the primary resource to be used for generation of the heat is the electric arc. Okay, now there is another process like gas welding. So in case of gas welding, we see that the burning of gas, like few gases like oxygen, acetylene, okay, so these are the different gases which will be mixed at the proportionate ratio, and this gas will, when this gas will be burned, so the burning of this gas will create a large amount of heat, and that heat will be sufficient enough to melt down or to fuse the parent metal edges. Okay, so once the molten stage reaches, the joint phenomena will be occur after solidification. Okay, so this is particularly about the welding joint. This is the introduction to the welding joint. Now welding joint is extensively used in fabrication as an alternative method for casting or forging, and as a replacement for bolted and riveted joints. Casting or forging, and as a replacement for bolted and rivet joints. It is also used as a repair medium, for example, to reunite metals at a crack, to build up a small part that has broken off, such as gear tooth, or to repair a worn surface, such as bearing surfaces. Okay, like this, you can see that it is fundamentally used in fabrication process. It can be used as a replacement of casting or forging method. Also, it is a permanent joint, so it can replace other fastening processes, other joining processes like here riveting, okay, like your bolting. All those are the primary joining processes. So as welding is a permanent joining procedure and is the one of the best joining method, and joining strength is much more high, so this welding method can replace other fastening method or joining methods like riveting, like bolting, etc. And also you can see that for repair purpose, welding can be best suited. Like here it is mentioned that anything that if there is any crack on metal surface, so in order to repair that crack, okay, in order to join the part which has been already broken off from the parent part, so in order to join that take up part from the with the parent part, so you require the method of joining. Next, come to the advantage and disadvantages of welded joints over riveted joints. First, start with the advantages. So you can see there are several advantages are there in case of welding method compared to the riveting. First one is the welding structure are lighter than the rivet structures. This is very important thing, that is quite lighter than the rivet structure. Second one, the welding joint provides maximum efficiency. It comes efficiency near about 100%. So in terms of efficiency, the welding joint is best suited compared to the rivet joint. Next, alternation and addition can be easily made in the existing structures. Okay, like in case of any existing structure, existing foundation, any existing structure, if you require any additional part to be joined, you can easily do that with the help of welding method. Now, welded structure is smooth in appearance, therefore it looks pleasant. Okay, so in terms of looks, in terms of the aesthetic beauty, the welded joint parts looks comfortable, looks good. In welded connection, the tension members are not weakened as in case of riveted joint. That means two metals you are supposed to joining. Now what will happen, that if one metal is under tension, so in case of other joint, if one part of the joint, if one metal of the joint parts come to the under tension, so that part may be subjected to a weakening tendency. So but in case of welding joint, you cannot see any case of weakening for the part which is under tension. Okay, this is a good thing. A welded joint has great strength. Okay, the members which are difficult to rivet can be easily welded. The welded joints are very rigid. It is possible to weld any part of structure at any point, but riveting requires enough clearance. Okay, that means you can weld any part of the structure. That is, it is very much easy to weld at any point, and it does not require any kind of clearance, or if you require any kind of positioning, the positioning problem is not there. But in case of riveting, you require some kind of clearance, some kind of gap, so that you can rivet the joints. Okay, so obviously in case of riveting you require some kind of clearance. Here you do not require any clearance in the case of welding. Okay, at any point you can weld easily. The process of welding takes time less than riveting, so time required is very less compared to the riveting. Now you find some disadvantages are also there in welding. First one is that since there is an uneven heating and cooling during the fabrication, therefore the members get distorted. Additional stresses may develop. So this is the most important problem in the welding. Okay, first one is the distortion, second one is the residual stress. Okay, two things that are very crucial problem in case of welding. One is distortion, another one is residual stress, and this is nothing but due to the uneven heating and cooling. Okay, second one is it requires highly skilled labor and supervisors. So supervision problems, the supervisor has to be a very much skilled, and also the labor who is working with the welded joints has to be skilled enough. Okay, in case of riveting, what happens that skilling is not necessary, although there is skilling, but that is not necessary as compared to the welded joint. The welder who is doing the welded part, the supervisor who is supervising or who is inspecting the joint efficiency, the inspector, the supervisor, the labor, all are must be very much skilled enough. Number 3, since no provision is kept for expansion and contraction in the frame, therefore there is a possibility of crack developing in it. So what happens? A welded joint is absolutely fixed and there is no kind of provision, no kind of clearance in any of the joint parts. So what happens? You can see that during hot atmosphere, the metals which are joined, so it has a tendency to get expanded, and during the winter season, the metals may be subject to contraction. So during expansion and contraction, the metals cannot get the necessary space to allow them to contract or to expand. So in case of welding, this is the most important problem, as the joint is heavily rigid and there is no clearance is provided for sufficiently for expansion and contraction of the joint. Next, number 4, the inspection of welding work is more difficult than the riveting work. The inspector who is inspecting the joint performance, joint strength, he has to be much more skilled, as I have told you before. Next is the welding process. The welding process may be broadly classified into 2 groups. Number 1, the welding process that use the heat alone is called the fusion welding. So in case of fusion welding, the primary resource for joining is only the heat. So according to the method of heat generated, a fusion welding may be classified as, first one is the thermite welding, gas welding and electric arc welding. Okay, so these 3 are primarily coming under the fusion welding. Now, as the subject is on design, so I shall not go in detail for every welding method. These methods you can find in your manufacturing book, production book. So thermite welding, that you know, thermite is a mixture of iron powder and aluminium. So here you can find that after a chemical reaction, thermite is produced. Okay, so thermite, basically this welding is employed for railway joints, railway line joining. Okay, now gas welding, that you know, oxyacetylene. Okay, oxyacetylene flame, oxygen, acetylene, both these two gases are used. Now electric arc welding, that you know, that TIG welding, MIG welding, submerged arc welding, manual metal arc welding, all are coming under electric arc welding. But one thing, remember that these three welding methods are under the fusion welding, because these three weldings primarily require only the heat. So there is no requirement to use the external pressure. Okay, only heat can be sufficient to fuse the edges of the metal which are to be joined. Okay, next come to the welding process. Second method is the welding process that use a combination of heat and pressure, that is called the forge welding. So in case of forge welding, like the examples of forge welding are the electric resistance welding. Electric resistance welding like spot welding, projection welding, seam welding, offset welding, flash welding, all are coming under the electric resistance welding. And in resistance welding, you can see that in addition to the heat, you require the external pressure also for welding purpose. Next come to type of weld joints. Following are the two types of welded joints that are important from subject point of view. First one is the lap joint or fillet joint. Second one is the bar joint. Okay. Now lap joint. Here you see this is the lap joint. Okay. This is the lap joint. That means one metal is placed above another metal. The lap or fillet joint is obtained by lap. The term is coming from the main term, that is overlapping. From this overlapping word, the term lap is coming. Okay. The lap or fillet joint is obtained by overlapping the plates and then welding the edge of the plates. Okay. Here you see the edges are joined, and one metal is placed above another metal. That means they are overlapped. The cross section of the fillet is approximately triangular. Here you see the cross section. So it is a triangular part. Okay, this is triangular. The cross section of this fillet is triangular. The fillet joints may be single transverse type, double transverse type, and parallel fillet type. Here you see this is a single transverse type fillet weld or lap weld. Okay. This is metal number 1. This is metal number 2. So above metal 1, this is 1. This is 2. Okay. This is the top view. This is the top view. This is the front view. Okay. This is the plan. This is the elevation drawing. So in the plan drawing, you see that metal 2 is positioned on metal 1, and the edge is absolutely joined by welding method. Now, if you look at the elevation drawing, you can see that this is the cross section of this fillet is approximately triangular. This is single transverse type fillet joint, but here you see this is double transverse, because at this edge, this particular edge is also joined and this particular edge is also joined. So two positions, two edges are absolutely joined by welding method, so that's why it's called double transverse. Okay, double transverse. Here you see this is the. Now one thing you will have to note that here the welding is done this particular way, from here to here, okay. But the axis of this, you can say the horizontal axis of this welded metals are like this. So that is perpendicular. So that is what is called transverse. Okay. Welding axis, this is the welding path along y-axis, or welding run along y-axis, and the x-axis represents the central axis of the joint metal. So here you see these two planes are absolutely perpendicular. So you can say this is a transverse joint. Okay. But here in the parallel fillet joint, you can see that the welding run is along the x-axis, and also the central axis of the joint metals are also in x-axis. That means these two lines are parallel to each other. So that is why it's called the parallel fillet joint. So here it is the top view, it is the plan view. Sorry, this is the elevation view. This is the top view and this is the front view. So this can see that both the edges are also joined. Both edges are also joined because here if you join the both edges, so what will happen? The joint efficiency will be much more enough. So that is why this particular both sides of these edges are joined by welding. Okay. This is parallel fillet. Okay, this is top view. So both these two drawings have to be represented. How it looks, how the joint looks from the top view, and how the joint looks from the front view. That is, one is from plan view, another one is the elevation view. Next, another method is the bar joint. Okay, now the bar joint is obtained by placing the plate edges to edge. That means if it is metal number 1, if it is metal number 2, so they are just placed beside each other. Okay, so this particular part is joined. This is called the bar joint. In case of lap joint, we have seen that one metal is absolutely placed over another metal, but here you can see these two metals can be placed just beside to each other. Okay, so edge to edge joint is there. Okay, this edge to edge joint. Now, in bar weld, the plate edges do not require any beveling if the thickness of the plate is less than 5 mm. That thing is important from objective purpose. If the plate edges thickness of the plate is less than 5 mm, you do not require beveling. On the other hand, if the plate thickness is 5 to 12 mm, the edge should be beveled to V or U groove on both sides. Okay, here you see in the drawing. V-bar joint, in case of V-bar joint, this is beveled like V shape. In case of U-bar joint, it is beveled like U shape. So that means you can say that the plate thickness is 5 to 12 mm. Okay, so that is why it is beveled. Also, you can see double V-bar joint. So both ends are beveled. Here also both ends are beveled in U shape. Both ends are beveled in V shape. Okay. So that depends on 5 to 12 mm of plate thickness, and if the plate thickness is less than 5 mm, then you do not require any beveling. Okay, that part you have to remember. So bar joints may be square bar joint. This is like this particular shape looks like a square, so it is called the square bar joint. Okay, the single V bar joint. Okay, this is a single V-bar joint. The edge to edge joining is done by the bar welding method, and here you see the joint part looks like a V type. So that is why it is called the single V-bar joint. Here the included angle. Okay, here the included angle in the V shape is 60 degree. Next, come to the single U-bar joint. Okay, single U-bar joint. Okay, this is single U-bar joint. The welded shape looks like a U. This is called double V-bar joint. So this is one V, this is another V. So two V are there. The joint looks like a double V shape. So that is why it is called the double V-bar joint. Next, come to the double U-bar joint. The welded joint looks like a double U. Here one U, here you see this another U. So the whole joint shape looks like a double U. So this is why it is called the double U bar joint. Next, come to there are several other type of welded joints like corner joint, edge joint, and T-joint. This is the corner joint, corner to corner. This is the corner of metal 1. This is the corner of metal 2. When corner to corner joint is done, this is called the corner joint. This joint looks like a L shape. Okay, this is L shape joint. Now come to the edge joint. Here you see this particular edge joint. This is called the edge joint, edge to edge joint. Okay. Next, T joint. So the structure after joining looks like a T. Okay. So here it is called the T joint. So one particular edge is joint here, another edge is joint here. Okay. So two joints are there, and the final welded shape looks like a T. So that is why it is called the T joint. Now, how you can select that which type of joint you require? So there must be some criteria to select the method of joining, to select the type of joining. Okay, so these few considerations are there. There are three criteria mainly. One is the shape of the welded component required. That is, if you require the L shape, T shape, corner shape, how it looks. So depending upon the shape of the welded component you require, so in that case you can select the type of joint. Okay. Next, point 2, the thickness of the plates. So as I already told you, the thickness of the plate is less than 5 mm. You do not require beveling. If the plate thickness is 5 to 12 mm, then you require the double U or V type of beveling. Okay. So that is why thickness of the plate also matters. And third one is the direction of force required. Okay, whether the welding travel, whether the force or welded travel length, depending upon the welded travel. Okay, whether you select the parallel fillet, whether you select the single transverse, double transverse, depending upon the travel, the direction of travel length of the weld. Okay, the direction of force, or you can say direction of the force. Next, come to the basic weld symbols. These symbols are represented in drawings. If you see any engineering drawing or any design, so you can see that the parts which are joined, so these symbols are absolutely there in those drawings. Okay, because it is not possible in a single drawing to mention all the different forms of weld in language. So that is why we use the symbol, and this symbol is internationally accepted. That means anyone in the world who is quite much understandable with the welded parts, he can easily understand that from this symbol what the designer wants to say. Okay. So if it is the symbol of fillet, square bar, this is the symbol of square bar joint. This is the symbol of single V bar joint. Symbol of double V bar joint, single U bar joint, double U bar joint. Okay. Just remember, just go through those symbols. Next, come to the previously it was the primarily symbols, main symbols, basic symbol you can say. Now it is the supplementary weld symbols. So here serial number 1, if you see, this is the particular weld all around. That means if you required welding all around the joint, so drawing representation will be like this and symbol will be like this. Okay. Field weld, that means in the field, in the manufacturing side, in the field, if you require joint, that means at the field sector, that is where the plant is just under construction, that field only, that the site place only, if you require the welding, so that will be the field weld. Okay, the difference between the weld, this is nothing but this the whole portion of the circle is totally making darken. Okay, so this is the symbol. the dark circle. Next is the grinding finish. Okay, so it is the grinding finish symbol and it is the drawing representation. Next, machine finish. So you see this is the machine finish drawing representation and this is the machine finish symbol. Okay, just go through that. Now elements of welded symbol, welding symbol. So welding symbol consists of total 8 elements. First one is the reference line. Here you see in the drawing. This is called the reference line. Okay. Next one is the arrow. Here this is the arrow. Basic weld symbols. Like basic weld symbol means how it looks. Like here you see this is the basic weld symbols. Dimensions and other data. Here you see this is the dimension, size. Supplementary symbol. Here you see this is the supplementary symbol. That means weld all around and also field weld. Finish symbol, that is F. F means finish symbol. Tail. This is the tail. Specification, process or other references. Okay. Here you see this T. T means it may be T welded. That means it the method of welding is also also mentioned here. Okay, so this is the complete shape of a welding symbol. So in drawing you can see like this. Okay, in design drawing. So this is the tail. This is the method of welding. This is the size of welding. Okay, like the size of the plates you can say if 2 5mm plates are joined. So obviously size of the weld will be, you can mention S equal to 5. Okay, then finish symbol. This is the basic symbol. Okay, both side arrows, other side like this. Now L means it is the length of weld. T means unwelded length. Now you must have to remember one thing, that the alphanumerical values or digits, alphabets which are mentioned at this particular position, so it cannot change that position. Like finish must be at the top head, so you cannot change the location of F. Like welded size, where S is mentioned, you have to mention the size only, you cannot change it. Okay, like here the weld around symbol, the field weld symbol, you cannot change. So these are all standardized, so you don't have you are not supposed to change all those things. Okay, so as it is written as per standard norms, so you have to mention that only. So for example, if you go the representation of welded symbol for any fillet weld, each side of the T. Now in the design, in the drawing, how it will be shown? A fillet weld, each side of T. So fillet weld, here you see this is the fillet weld. It is the both side of the T, and the length you see, the size of the weld is 5mm. Okay, so it looks like a right angle triangle. So the base is 5mm and the height is also 5mm. So size of the weld is 5mm. So it will be symbolized like symbolically, if you can represent like this. This is the T weld. This is the arrow sign. Okay, and arrow head looks like this, and on the arrow at this particular position where 5 is mentioned, 5 means the welded size. Okay, and this is the symbol for fillet weld. Next you can see the single V-bar weld machining finish. Okay, this you can see that this is the single V-bar weld, and here you see this is the symbolically you can represent like this. So this is the arrow sign, and this particular thing, that means it is a machining finish. Okay, here you have already got this thing, that machining finish means this is the machine finished. Okay, so this symbol has to be incorporated here. Now similarly double V-bar weld it looks. So double V-bar weld, it looks like this, and if you can symbolically represent in design, so it will be like this. Okay, so there are several representations you can find in your textbook also. The main important representations I have just drawn here, I have shown you here, and for your interest, if you can go through in your textbook, so you can find lots of representations of different welding symbols.